Okay, what we did previously, we looked individually at series and parallel circuits. Here in our notes we have a table where it lists side by side to compare, and you have to have this memorized. And the reason you have to have this memorized, not only to do series and parallel, but today when we're going to do combination circuits, you are applying these within the circuit. So in series, the resistances add up. So the equivalent resistance, so again, we're using RT here just to make it easier for us, but this is the equivalent resistance. So the equivalent resistance in series is R1 plus R2 plus R3, etc. The current is the same throughout when something is in series, and we're going to use this. This is important when we're to know that these are the same or equal. So when I say to you, what is the same? When I say same, I mean equal. And then in series, the voltages add up. In parallel, to find the equivalent resistance, 1 over the equivalent resistance is 1 over R1 plus R2 plus R3, etc. The difference is the current adds up in parallel, and what's the same or equal is the voltages. Now, when we do these problems, what we have to do is it's kind of like order of operations in math. We can't just start adding or multiplying or dividing. We have to look at what we can do. And the way to do this is by looking at the current. The current is going to tell us whether something's in series or parallel. We're going to be applying Ohm's law over and over and over again throughout, consistently. And we can apply this for the entire circuit, we can apply it for part of a circuit, we can apply it for one particular resistor. We're going to today be doing intermediate schematic diagrams. The intermediate schematic diagrams is the only way to do these problems. So you're going to do your intermediate schematic diagrams, and we're going to use those, and this is going to be simple. Okay? So here's our example problem in the notes that I'm going to work out step by step. Okay? Now, when we're looking at this is my source, my battery. I have 120 volts. Now, what's going through the wires here, this is the current. So coming out of the battery, I'm going to have my total current. Then the total current's going to go through this resistor, but when it gets to this point, it's going to divide. Now, part of it's going to go here, I can call this I4, and then part of it's going to go here, which I can call I2. But what happens is the same current that goes through here goes through here. So these two are not in parallel. These two are not in parallel because there's another resistor here. Now, if I add these two in series, this equivalent resistance is in parallel with this. So what I'm going to do is I'm going to work this on a separate sheet of paper. I believe you already have this worked out, so you're just going to pay attention and follow along. So the first thing I'm going to do is I am going to redraw my original diagram. If your resistors aren't labeled, you should. So the source is 120 volts. R1 is 4 ohms. R2 is 3 ohms. R3 is equal to 6 ohms, and R4 is equal to 18 ohms. The whole purpose of this is I want to simplify. What I want to do is I'm going to go down and I'm going to simplify till I get one equivalent resistance. And my one equivalent resistor is going to be RT. So first of all, I have my total current. Here it divides. I can't add these two in parallel. This is in between. These two are in series. How do I know these two are in series? The same current that's going through here is going through here. Remember, when you're thinking about circuits, and you should conceptualize water going through a pipe. The water is the current. So the water that flows through here is the same, but now there's two pipes, and part of the water goes here and part goes here. But what's flowing through here is the same as what's flowing through there. So I know these two are in series. So what I'm going to do is I'm going to redraw this. And I'm going to leave R1 alone because I'm not touching that. I'm going to leave R4 alone because I'm not touching that. And instead of R2 and R3, I'm going to combine them with a resistor I'm going to call R23. Now, how do I find the magnitude of R23? Well, these two are in series, so R23 is going to be equal to R2 plus R3. So that's going to be 3 ohms plus 6 ohms, so R23 is going to be 9 ohms. So now this is a 9 ohm resistor. Now I see that R4 is in parallel with R23 because the current divides. So if I want to find an equivalent resistor, oops, I forgot that one. R1 stays the same. So now if I want to add these two in parallel, I'm going to call this R234. Now, how do I find R234? So 1 over R234. Why am I saying 1 over? Because these are in parallel, and that's how I add resistors in parallel. So 1 over R234 is equal to 1 over R4 plus 1 over R23. So that's going to be equal to 1 over 18 plus 1 over 9. Do you notice these have really easy numbers? Remember I said that most of the time textbooks use whole numbers, and they use whole numbers so you can easily find a common denominator, so you can practically do the math in your head. So if I find a common denominator here, which is 18, 1 over R234 is equal to 1 over 18 plus 2 over 18, which is 3 over 18. I can reduce that to 1/6. So 1 over R234 is equal to 1/6. Now remember, R234, I have to cross multiply, so this times R234 is not equal to 1/6. When I cross multiply, R234 comes out to be 6 ohms. So now this is 6 ohms. Now when I look at this diagram, what do I see? I see I have two resistors that are in series. So what I can do is I can redraw it, and I can have one resistor I'm going to call R1234, which is also, I could call it RT if I want. How do I find this? So R1234, I add them, is R1 plus R234. So I'll just call it T, so that's equal to, this one was 4 ohms plus 6 ohms, and 4 plus 6 is equal to 10. So this, the equivalent resistor is RT. Now, they already told me that VT was equal to 120 volts. If I have V and I have R, what can I find? I. Because I can use Ohm's law, V is equal to IR. I can apply it to the entire circuit, so VT is IT times RT. So IT is equal to VT over RT. So it's 120 volts divided by 10 ohms, so it comes out to be 12 amps. So the total current coming out of the battery is 12 amps. So that means what's going through this resistor, this I is equal to 12 amps. This is the point now where I start working backwards. I take my intermediate schematic diagrams, I look at how I added my resistors, which tells me the relationship is something series or parallel, and then I look at what is the same, and then I use that. So what do I mean? All right, these two resistors were added in series, right? So in series, what is the same? Current. Remember this chart? In series, the current is the same. So what that means is, if this is 12 amps, that means this is 12 amps, and this is equal to 12 amps. Well, what am I going to do with that? Well, if I have R and I, what can I find? V, right? So the voltage drop here, V is equal to IR. So 12 times 6. 12 times 6 is 72. And then here, V is equal to IR. 12 times 4 is equal to 48. Now, What is so great about circuits? What is so great about circuits is you will never make a mistake because you have a foolproof way, as long as you know this table, to check your work as you're going along. So what do I mean? These are in series. In series, the voltages add up to the source. Remember, in series, the voltages add up. So this plus this must add up to the battery. We know the battery is 120 volts. Is 72 plus 48 equal to 120? Yes. So now I know I have not made my... All right, now we're going to go back to this diagram. How did I get R23? So what happened was R234, this resistor here, was from adding these two in parallel. So now I'm going to say to myself, what is the same in parallel? What is the same in parallel? So I'm going to look at this chart. What's the same in parallel is voltage. So whatever the voltage is here, 72, that's the voltage here and the voltage here. So this is 72 volts, and this is 72 volts. If I have V and R, what can I find? I. So I is equal to V over R. So it's 72 divided by 9. 72 divided by 9 is 8, so that's 8 amps. Over here, I is equal to V over R, so it's 72 divided by 18, which is equal to 4. But you know what? I want to check my work. These two resistors are in parallel. In parallel, the current adds up. So these, what's coming through here, I know the total current is 12 amps. Did I already figure that out? So these two must add up to 12. Is 8 plus 4 12? Yes. So again, I'm checking my work. This is what makes circuits so easy. As I'm going along, I check it. Is this correct? All right. So now, this resistor here, R23, I found by adding these two in series. What is the same in series? In series, the current is the same. So if R23 is 8 amps, that means this is 8 amps, and that means this is 8 amps. So I2 is 8 amps, I3 is equal to 8 amps. So what I'm going to, if I have R and I have I, now I can find V. So V is equal to IR. 8 times 6 is 48 volts. Over here, V is equal to IR. So V is equal to 8 times 3, which is equal to 24. Now remember, this voltage here and this voltage here, these two are in series. In series, the voltages add up. So 24 plus 48 needs to come out to be 72. Is 24 plus 48 72? Yes. So I checked my work. And I'm trying to think if I found everything I need to find for this problem. This one, the current is the same coming out of the battery. So here we already found that one. That R1 was 48 here. So we found everything we need to do for this problem. So what you do is when you have a complex circuit, as long as you're given all the resistors, what you do is you keep simplifying it till you find an equivalent resistance. Once you get your equivalent resistance, if you're given the voltage of the source and you have the total voltage and the total resistance, you can find the total current by using Ohm's law. V is equal to IR, I is equal to V over R. Then the only way to do this is going backwards using your intermediate schematic diagrams. There's no shortcuts. You can't do this in your head. So this is the way to do this correctly. Not memorizing a certain problem, not memorizing something. This is to understand it. So then when we get to more complex problems, this is simple. This is the correct way to learn circuits, by understanding it and not memorizing. And again, these are the steps that we take in order to solve a problem.